Hello.
Yes,
Hello.
sir. Good evening, sir.
Yeah. Good evening. So, can you hear me? Yeah. There was initially some problem over there. Okay. Okay. Let me put this one. Can you see the screen?
No, sir.
Can you see?
No, sir.
You cannot. Just hang on.
No, sir.
Huh?
No, sir. We cannot see it.
You cannot see it. Okay. Fine. Let me check. Okay. Just hang on. Okay. Now, can you see?
Yes, sir.
Okay. All right. Okay. Oh, okay. No. Why I got lecture 16? Oh, okay. It would be lecture 17. Okay. Today is earlier one was lecture 16 or 17. I forgot. That one was 16, most probably. Okay. So here it is. Okay. Today a little bit late that we are having this confidence interval. We started that on the day of exam, midterm exam, but we had to postpone this midterm exam. Okay. There was some technical glitch over there. Still, until and unless it is stable, we are not very much sure. We are not going to hold this thing, and hopefully it will not be before Chhat. Okay. Uh, some people have requested for holding it too late, that is after 25th. What's the reason? Are you going out of station? Can you hear me? Hello.
Yes, sir.
Are you going out of station? Are you going out of town? You are not. Okay, I don't know why. Because if I make it further delay, what will happen? All your exam will come up at the same time. Your end same, midterm, everything. So I wanted to have this distributed. So certainly I'll not hold it on in the week of this week. It will not be. Okay. So don't worry for that one. If it happens, it will only happen on 23rd or 25th, not before that. Okay. So in any way, you will get information. It will be posted either through your WhatsApp or a Google Class. So don't worry about that one. Just you be ready with what it is. Uh, you know the content. So it will be just your revision. That's all. Okay. Nobody is going to ask you too many hard question or anything. It's everything is known. Only thing that we want you to work out. That's it. Okay. Now let's talk about the confidence interval. Okay. See, whenever we started at the very beginning, what we said that uh, out of the whole population, we took only a small sample. Okay, and we did the analysis of that sample, and we called it statistic. Okay, and there we calculated the mean or median or variance or whatever it is. Okay, so how we can get the whether we have to know whether that mean that is calculated based on sample, okay, whether it is going to represent the value of population. Let's say if I say in NIFT, okay, I am taking only a sample of 10 students, and based on their performance and everything, I want to have a generalized impression about NIFT of total number of students, right? So whatever that sample I take, whether it can give me that much confidence that, okay, fine, I have taken this number of students who are going to be real true representative. So based on that, I can easily say that whatever result they are getting, that 95% of their result is going to give, represent the whole NIFT. If there are 4,000 students, I don't know how many you have right now. Okay, so total population is going to have the it is going to represent that one. So that's what it is. The first line says that it is the interpretation of confidence. Okay, that confidence interval for the population mean based on the sample mean. Strictly speaking, a 95% confidence interval means that if we are to take 100 different samples and compute a 95% confidence interval for each sample, then approximately 95 of 100 intervals will contain the true mean value. Okay, so whatever that is, it will always give the that 95% of the 100. Okay, once we show this thing through some example, it will be clear. Sometimes it may sound very abstract in a statistic, but until and unless you work out, it doesn't get. So in practice, what we do is that we select one random sample and generate one confidence interval, which may or may not contain the true mean. The observed interval may over or underestimate mu. See, there are two things you should always keep in your mind, and you keep it clear that X bar is the mean sample mean. Okay, while mu is the population mean. Okay, similarly, S is the sample standard deviation. Okay, while sigma is the population standard deviation. So you keep always this difference in your mind so that it never makes any confusion later on. Okay, now basically rather it reflects the amount of the random error in the sample and provides a range of values. So whatever the sample you have taken, there will always be some error. It is not going to be 100% correct, right? You are going to represent the whole population. So there will be some error. And another way of thinking a confidence interval is that it is the range of likely value of the parameter defined as a point estimate plus margin of error. Okay, point estimate means that is whatever you have estimated based on the sample plus minus error, so that it will say that, okay, fine, that with a specified level of confidence which is similar to probability. That means whatever the value, if you say that, okay, this mean I am going to tell, so there is going to be some plus minus error that is going to have. So it is some kind of a probability that it may be close to this so much 10% plus minus this. Suppose we want to generate 95% confidence interval estimate for an unknown population mean. That means you are trying to calculate mean based on sample mean. Okay, and you want to have a 95% confidence. That means there are 95% probability that confidence interval will contain the true population mean. That means whatever you are calculating based on your sample mean, that population mean will be within 95% probability. Okay. So there will be P, probability sample mean, minus margin of error, and this mu value, that is your this population mean, that will be lying within minus and plus. It's just like tolerance. You might have already have this one measurement tolerance. There where we say that accuracy is plus minus. So if you have some kind of a measurement or any machining, especially in manufacturing science, this is used. So it is just like your plus minus. You take the mean value, you know that okay, fine, this is my mean value, and there can be variation plus or minus. Just like in your machining, if you produce something in lathe and you want to have a diameter of, so let's say, phi is equal to 20, you know that it's very difficult to have this exactly. So you always say 20 plus minus zero point 0.2. That means you know that it is tolerance is 20 plus 2. It can be on the higher limit, and in the lower limit it may be 20 minus zero point 0.2. So you always, it is just like that, similar to that. Now, it's the same thing what I told you, that in general we have a sample mean X bar. We are using it as a guess or estimate for the population mean mu. Okay, and hence it would be useful if we could have an interval based on X bar, that is with X bar in the middle. And it is same thing. Uh, it's better to have a look. I'll give all this thing to you later on, then it will be more clear. Okay. Now, if I tell this thing, it will become, sometimes it is very much, it sounds abstract. Okay. So I'm only telling you only those slides which are which you understand, you will understand, and rest of the thing I'll come back later or next day, so that you can understand better once it becomes clear. Now, an interval of values computed from the sample. What is the definition? Confidence interval is an interval of values computed from the samples that is almost sure to cover the true population value. That means you should tell from this sample value that it is going to cover everything. Okay. So we make confidence interval using values computed from the sample, not the known values from the population. It's not the other way around. What is your objective? Your objective is to get the population. So you are not going to get it from the known values of the population. What you will do, that based on your confidence intervals, okay, and that will be samples. When you put confidence interval on sample, it will give you the population. So interpretation, in 95% of the samples we take, the true population proportion will be in that interval. Okay. So it would cover 95%. It's not 100%. It's, I mean, that kind of guarantee it gives. Okay. So you have to think in that way, that confidence interval. In general, we construct such intervals so that should we repeat the process a large number of times, it's just like, in any experiment, there is a term called repeatability. Okay. Or what is the meaning of the term repeatability in any experiment? Anybody? What is repeatability? Hello?
Yes, sir.
Yeah, what is repeatability in any experiment? Can you guess, or what is the term in repeatability? Have you heard? Why do we need to repeat the same experiment several times?
It will measure the variation, sir.
Right. So it has to say that if I repeat the same experiment in the same procedure, okay, whether I reach the same result or not. Okay. So that's why it is if you perform some experiment, one has to, at the end, one has to, if it is you are going to follow the right way of doing experiment, there you have to say that repeatability answers this result. Repeatability is so many percentage. If you say 97% or 95%, that means 90. If I repeat it, that means 95% of the cases I arrive at the same result. Okay. So that's what, just like in I don't know whether you have come across the word patent. And actually, one of the requirement of the patent in international patent is like that, if somebody follows one has to reach the same result. If it doesn't, then it doesn't qualify. Okay, so that's the question. Most of the time, this examiners ask, what is the repeatability of this experiment, or whatever the methodology you have followed, whether how many, it's similar to that. Just like, should we repeat the process a large number of times? The 95%, for a 95% confidence interval of such intervals should contain the population parameters. That means if we repeat, okay, so 95% of within that confidence interval, that means so many plus minus, your population result is bound to come. Okay, if it doesn't, that means being estimated by the point estimate. That means it has been estimated from the sample value and with that confidence interval. Okay, so many times, if you do it large number of times, fine, your result is going to come within that range. So that's the whole meaning. And rest of the things are just like, sometimes it may sound abstract to you. If you read some book, from one book to another book, you will come across. So only thing that you have to grasp the meaning. Okay, so what we need to do is, confidence interval is that, okay, we have to specify some interval, just like in machining you give the tolerance plus minus. Okay, that you say, okay, my machining, whatever I have machined, whether this bore or whatever it is, that length, it's a plus minus. So here, to calculate a confidence interval, you have to decide on your confidence level first. Okay, size of the interval is determined by the size of the confidence level that we choose. Okay, if we choose a higher C, okay, if you want to have more accurate, that means its confidence level is 98%, 99, 100. That means you are trying to reach a perfect level, right? So if that's what it is said, that if you choose a higher C, we end up with a larger interval and vice versa. That means your plus minus range will be, that is going to go to a higher value. Okay, so maybe in case of your, let's say your dimension, it has to say, okay, my that range will be higher and higher, so as to have the higher confidence. Otherwise, if you narrow it down, means that is okay, fine, your interval will be lower and the confidence level will be also lower. So it is just from the common sense you can understand. It's just, if you want to have a, I mean, within narrow range, it is certainly, it may not be. Okay, so similarly in the reverse way, okay, if you widen your areas, the scope, certainly it is going to be, your tolerance is going, level is going to be higher and higher. So your confidence level, okay, you can say that, okay, fine, I am going to have 98%, 99%. So the construction of confidence interval, the whole chapter basically is that you have to specify what is the confidence interval and how you can construct such thing. Okay, how you build up. So if a problem is given to you, that means you should be able to tell. So a confidence interval for population mean depends upon three factors: the point estimate of the a population, that means point estimate means that is from the sample. Okay, the level of confidence, how much is the standard deviation of the sample mean, that means how much that, certainly you know that, what is the meaning of the term standard deviation. Standard deviation means that is how much the variation that happens in the data of the sample. So if I say the sample mean has got higher standard deviation, you physically understand that all this value of the data, they are widely sparsed. Okay, they are not very close to each other. That's why this sample mean has got the higher standard deviation. So certainly your this confidence interval that depends on this, also on the level of confidence, and this point estimate of the population. So all these thing, it's just like a, everything gets accrued. So it is the summation, you can say, at the end, whatever the good thing that comes up, whatever the bad thing that ends up in the bad thing. So one has to suffer. So similarly, the case is here that it gets reflected over there. Okay, so I think this is a repeat presentation. Last time also, I showed to this that we are given, okay, we are having these values for this sample statistics. X bar is mean, okay, the variance is S square, this is X1 bar, X2, whereas for the population parameter, this is the mu value, this is variance sigma square, or the standard deviation will be sigma, okay, and the difference mu1 minus mu2. Okay, so difference between two means, so two sets of data you will be having here, also two sets of data for two sets of samples, x1 bar, x2 bar. Now, let's come into some problem which may, if it is realistic problem, then it may be sound it. It looks, then you understand better way. A random sample of 32 textbook prices, rounded to nearest rupees, is taken from a college bookstore. Find a point estimate for the population mean mu. Okay, see you can have a look, okay, that how it looks like. Okay, uh, um, well, it was in other unit, I just changed it to rupees, because in rupees you cannot expect nowadays. When we are student, we used to have this price of the books in that range. Nowadays you don't expect below anything below 500 rupees, right? Okay, most of the books are very expensive, maybe 1,000 or 900 or so. Okay, so here it is 32 textbook, their prices are given, okay, in rupees, and uh, these are all samples, right? These are all sample data. Okay, now from there you have to estimate population mean. Okay, so maybe there is a big chunk of 1,000 or 2,000 books. How do you get it? Now, what it is done here, you see here that X bar, that is the mean value of these samples, is calculated, which is 74.22. Okay. Now, the point estimate for the population mean of textbooks in the bookstore is rupees 74.22. So that's basically the sample mean which has been calculated. So what you have to do from this point estimate, that's what it is called. This is point estimate, from which you have to get what is the population mean. So basically your job is to, it is some kind of a extrapolation, right? I think all of you have done some extrapolation, right? So you have, I think you have you taken already numerical methods in engineering? Okay, there is some terms called, okay, extrapolation, numerical methods. I think also in your second year or third year it is done. Okay, forward difference, backward difference, or something like that. Okay, or also some extrapolation or interpolation. So it's just like it is, you are going to have some extrapolation from the point estimate to this population mean that you have to calculate. Okay. Now, okay, an interval estimate is an interval of range of values used to estimate a population parameter. Okay, this is another term. Okay, so what you need to do is basically that you know that this is the average, this is the, uh, all of you know that, okay, find that, okay, this one basically, okay, this is the sample mean. Okay. Now you have to estimate the interval in which your this total total population mean lies. Okay. Okay. So that's the thing. Basically, you are going to estimate from the value of the samples. Okay. And now your job is to get what is the value for the population mean. So you have to know this is unknown. You do not know whether it is how many plus side, how many minus side, whether it is plus 5 or minus 5 or plus 3, minus 3. That's the job basically. Okay. So that is the interval estimate, what it is called. Okay. Now, another term that we already told is that level of confidence is the probability that the interval estimate contains the population parameter. Now, okay. All of you are familiar with this, okay, that you have already seen this thing earlier, okay, when we had gone through this normal distribution and all these things, and there we showed that z is equal to 0, okay, z score, okay, and we showed that that in one side this is the curve is something like that. If I said that if it is okay, what is the value area under this z is equal to plus 0.9 or so, okay, or anything that is below or in between these two, you have already seen all these things, right? So here it is zc and minus zc you can easily calculate, okay. So anything that is beyond that is equal to half of 1 minus c. What's the reason? If I say this thing as C, total is C, that means it is 1 minus C. Okay. Now, in one side, this is half. That's why half of 1 minus C. Similarly, on the other side, this is half 1 minus C. So, all this area equal to this area. Okay. So, you can calculate this. You can easily get the value of C. Okay, area beneath this thing. Once you know the value of z, okay, from the table, that's why it is said that use standard normal table to find the corresponding z score. The remaining area in the tail is 1 minus c. And what are these z and all these things? These are nothing but the probability. You remember we had some examples in the last chapter also. So if you say it is 95% or whatever it is, then you can easily understand that what is going to be this C and everything. Now, again, we come to this thing here. You see that level of confidence, if I say level of confidence is 90%, that means we are 90% confidence that the interval contains the population mean mu. Okay, so let's here. And if I say 90%, you see the beauty of here is if I say it is 0.9, that means how much we are left with? That is 1 minus 0.9, right? So we are left with just 0.1. Okay. If I, okay. So that 0.1 is divided into half of this, half of on this side. So that is 0.05. And on this side, this is 0.05. Okay. So if I say that all my values have to lie within this area, okay, that is 0.19%. That means the rest of the thing will be only this side and this side. Okay. And from there, I can easily, if I look into this, I can easily get the value of Z score. So it is just reverse. If you recall in the table, you remember there was Z value and corresponding all these probability values that are listed there. So we are looking into their 0.1 or let's say 1.7. Okay. Then at the top, it was just like 0.1, 0.2, something like that. So here what you have to do is basically, what you have to do is basically you look into some values, and from there you look into search and get what is the value of Z. Okay, so from here, if anybody specifies that the confidence level is 90%, you can easily say that, okay, my Z score is this. So Z score is this means, x minus x bar divided by sigma. That gives you, and you can easily calculate what are the corresponding values that are required. Okay. Similarly, I can have the level of confidence as 95%. In earlier case, the confidence level was 90%. Okay. So here, if you see that this is 95%. Earlier it was 90%. Okay. Now that means we are going for more precision. This means that we are 95% confident that the interval contains the population mean mu. Okay, so what it happens is basically, just I missed something. Yeah, okay. So here, if I take 95%, that means 1 minus 0.95 basically is that it is 0.05. Okay, and 0.05 is distributed to the each side. One is 0.025, another is 0.05. Again, the same procedure. From the table you have to go, okay, and you have to search where you are getting 0.95 and get the corresponding Z value. I have missed that Z value here, that's why I'm not getting here. Okay, so, okay, so in the next case, if the level of the confidence is 99%, that means we are 99% confident that interval contains the population mean. So if you take 0.99, that means only 0.01 is left. Now you divide this thing, half of that basically would give you this value. Okay, so that on this side it is this, and another side it is just like this. Okay, and you look into table 99%, and from there 0.99, and from the table you will get ZC. That means Z value is 2.57. On the other side it is minus 2.57. So that's basically the technique. So if anybody asks you to find what is the confidence level, okay, or how, in a reverse way you can also get that what is the level of confidence, right? Suppose if it is given what is the mean value and everything is given, so from there you can easily have the value of Z value, and you can get what these corresponding values that you are getting from the table. So you can tell how much percentage of the confidence interval. You understand my point? Okay, so just like if anybody says that, okay, fine, this x bar is this much, and you want to have sigma value this, mm, easily you can calculate that what is going to be the level of confidence that can um, give you. So uh, basically, in words, if we want to, so far we are showing you in numerical ways what are the how to calculate and all these things. Now we come to some words, that 95% confidence interval. The goal is to capture the true effect, that is the true mean most of the time. Okay. So that means from the sample mean, you want to have basically a population mean. A 95% interval should include the true effect about 95% of the time. I repeated this thing. Now again, it is being repeated. A 99% confidence interval should include the true effect about 99%. So saying all this thing means that basically it is some kind of a guarantee that it would be that 95% of the time I'll have. It's just like in a shop, they say, okay, this is the guarantee that 1 year it would be lasting. Just like that, whatever you compute, say that, okay, fine, 99% of the time, if I say that confidence interval is 99%, that means the true effect would be included 99% of the time. Okay. Just like in any product, okay, as because you are in manufacturing, I think all of you need to give some kind of a certification, or you will be giving the certification in your job that what it is. Just like I have seen in Tata Steel also that uh, whenever any hot rolled coil or this cold rolled product that is sold to any automotive industries, okay, so most of the time it goes to Toyota. Earlier it used to go to Toyota, otherwise it goes to Maruti or Tata Motors, okay. So there the company has to give a certification that, okay, YS UTS of our coil lies within this and so much confidence level. That means I think YS is yield strength, okay, UTS is ultimate tensile strength, and another is percentage elongation, EL. So uh, they give that much guarantee that it has that much ultimate strength, okay, why an yield strength, okay, ultimate tensile strength and yield strength, okay. So and it would certainly, so if it is examined anywhere or any if you put it under universal testing machine, certainly it has to it will follow that norms, and okay, it has got that will be within the range plus minus, and I give this so much confidence level, this, okay. uh, until and unless this certification is done, okay, the car manufacturer will not buy this thing. Okay, nobody would. Okay. Okay. Now we'll go to this mathematical things. Okay, and suppose we obtain a simple random sample from a population. Most of the time, that's the way we do, provided that the population is normally distributed or the sample size is large, and the distribution of the sample mean will be normal with mean is equal to mu, and standard deviation is equal to sigma divided by root over n. You just again refresh your memory and look back into how we have come up. Okay. Now, if if all possible random samples, each of the size n are taken from same thing, it is repeated, have mean mu x bar is equal to mu, standard deviation sigma x is equal to sigma divided by root over n, and be approximately normally distributed large regardless of the sample of the parent population. Okay. Now let me show you how it comes up. The confidence, and now everything has got some margin of error, which we are talking so far in terms of the word tolerance. It's just like that. A confidence interval is uh, expressed as mean plus minus m. M is called the margin of the error. Example 120 plus minus 6. In this example, M is equal to 6. That means you allow so much tolerance. That's in another word, it is given here as margin of error. So different just terminology. It's nothing, I mean, great in it. If you understand this thing, fine. Whatever you have used in over there, you can think about in terms of that, basically. In your machining or in tolerance or metrology, you use the term tolerance, this, that, basically. Here it is the same thing. Okay, so confidence interval may be expressed as plus minus 114, 126. I already told you, if it is 120 plus minus 6, that means upper limit is 120 plus 6, and the lower limit is 120 minus 6. So that's what you have confidence interval that you have come up. Now size of M, okay, how much would be the error, okay, that will be determined by our desired confidence level. So it all depends whether you want to have 95% or whether you want to have 99%. Okay, that confidence interval would determine this M. It is going to decide. So either maybe it will be larger just to cover higher confidence level, or it may be lower. So vice versa. So that's what it is said. The higher confidence C implies a large margin of error, which in turn means a wider confidence interval. Okay, that means if you have the wider area, okay, that means a larger margin of error, then only you can have higher confidence interval, maybe 99%, 98. A larger confidence interval means less precision in your inference conclusion. So that is bound to happen. That means you are having more error that is creeping in, just like that. Now, okay, one more point is that one is that sampling error. What is sampling error? Basically, you are calculating the population mean or population terms, everything from the your point estimate or the sample, right? So from sample mean, you are trying to extrapolate whatever it is term you use for the population. So the difference between the point estimate or the sample value and the actual population parameter value is called the sampling error. Okay, that means you have it is as if you have picked up such kind of sampling which led to that kind of error. So it is your it is the error involved with your sampling technique. Okay, maybe there are another chunk of samples. If you had you picked up them, then you might have, or you would have reached the better result for population parameter. Okay, that's why it is termed as this sampling error. When mu is estimated, that means basically you are estimating the population mean. Sampling error is the difference mu minus, that is x bar, right? It is not typed here. Since mu is usually unknown, the maximum value for the error can be calculated using the level of confidence. So okay, so that would give you basically the error, sampling error. Now, given a level of confidence, the margin of error, sometimes called the maximum error of estimate or error tolerance. So the same thing has got different, terms. Okay, E is the greatest possible distance between the point estimate and the value of the parameter it is estimating. Now we'll see how that value of E comes up. So whatever that margin, okay, we so far we got that margin of error. We already termed that one here. If you recall that this is margin of error. Now we did not say how this margin of error has come. That we have to basically we have to calculate. We have to show how it comes up. Okay. Now that error is nothing but it is ZC sigma x, that is ZC sigma divided by root over n. We have already shown that sigma. You again refresh your a little bit, brush up, go back, and how those values are there. You again look into there. Okay. Now when n is greater than or equal to 30, the sample standard deviation S can be used for sigma. Okay, so S is the term that is used for sample standard deviation. So what does it mean? That means that n is greater, that means number of the samples is more than 30. In that case, S can be used as for sigma. So instead of uh, sigma, you can use this thing as S. That's what it means, basically. Now, a random sample of 32 textbook prices is taken. It's the same example we are talking about. The mean of the sample is X bar 74.22 and the sample standard deviation is S 23.44. Use a confidence in level and find the margin of error for the mean price of all textbook in the bookstore. It is just one example that it is talked about. Now, what it is, basically, if you look there, if you recall, earlier we showed that 95% that gives the Z value of 1.96. So that's what it has been put simply. If you recall there, okay, these two values that it was shown that it is 1.96. So that ZC has been put here. This ZC was, okay, that was 1.96, and you can go into your table from the textbook. You can look there, you can check there. Okay, and sigma value is here, it is this S is equal to 23.44 and root over n is equal to root over 32. That gives you that error, how much the margin of the error that would be coming up, that is 8.12. And it is says that since n is greater than 30, S can be substituted for sigma. So this S value has been substituted here to show how much the error that you can put, okay, margin of error. We are 95% confident that the margin of error for population mean all the textbook in the bookstore is about rupees 8.12. Okay, so that is the margin of the error that is calculated like this. Okay, now I don't want to go further just by saying this thing, that population mean in that case would be that population mean, we know that mu, it would be X bar, that is the sample mean, minus E, it is lower limit, and here it is going to be X bar plus E. So you just refresh your, again you go back and try to brush up your old memory, look into those things. So as you can see, it is basically talking about only mean and standard deviation. So you have to be very, very careful about that chapter and try to differentiate between the sample mean and the population mean, sample standard deviation, and population standard deviation, because the standard deviation calculation, that equations are different, okay, for sample value and for population value. Okay, I wrote that one. Maybe it will come up several times in your homework or somewhere, so you be very careful about that thing. So I don't want to bombard your mind today with more things. You better look into all these things, and we'll stop here. Okay, uh, with this, and next time also we'll have class on 18th. Okay, as I said that we do not want to have exam in this week, and not before chat at least. Okay, so you are relieved in that sense, but I don't know about whether it is going to be 23rd or 25th. It all depends about the stable situation. But anything that happens, it will be, will be notified. Okay. So if you have any point to know or discuss, let me know. Otherwise, we'll wind up. Yeah, Pap. Hello. Is it all right?
Yes, sir.
Yes. Okay. So, any question? So it's always better to brush up. That's what. Sometime it doesn't give you uh, in the class whatever we speak sometimes. Okay. So what I want to harp on, I want to just repeatedly I'm saying that look into the mean median, that chapter very minutely, and that would be better off. Okay. I'll try to set up some homework, but certainly all these things will not be due before your chart. So enjoy your chart, and we'll be before chart. We'll be meeting on next Wednesday. Okay. All right. All the best. Okay. Okay.
Thank you, sir.
Bye now. All right. Welcome. Good night.